So hello, today I wanted to explore with you the concept of pull-up resistor in practice. So for this, what we first need is, of course, some kind of voltage source. Here I have this 9-volt battery. It's nominal 9 volt. And let's put the positive rail down here and the negative rail in up here. So I'll show you a little bit closer. The positive rail is connected on the bottom, the negative rail is connected on top. Now we can, first thing perhaps to do, let's turn this around. First thing to do is to measure what voltage the battery really has. So here one and then the other plug. Switch on the multimeter to volts. It measures some kind of millivolts right now. Levels out. Okay, now we measure from positive. So there would be around 20 millivolt error, but let's see how that works out. We measure the plus pole and the negative pole, and we get 9.44 volt. And our 20 millivolt, I mean, that means we had to subtract that error perhaps, and then we would be at 9.42 volt, but that is negligible. We can neglect that. So it's around, let's say this is battery is about 9.4 volts. I want to see what happens, because we are speaking of pull up and pull down resistors. This video now is about a pull up resistor. Yeah, that's the resistor that we want. Let's start from left, so 1, then black is 0, then another black is also 0, so we have 100 with the first 3 rings, and then the 4th ring from the left is brown, which means a multiplier of 10 to the power of 1, which means 10. So we have the left 3 rings, 100 times brown times 10, 100 times 10 is 1000. So this is a kilo ohm resistor. So we use this as a pull up resistor. Pull up, so this means we have to pull it up to our positive supply. So let's do this and connect it here to our positive rail. So, and now the thing is, we want to know, okay, which point are we interested in? It's very important. So which point of the circuit is pulled up? And so we have 2 options. Oh, the cat is walking by. We have 2 options, and the first one would be, okay, this point here is our point of measure. It could be this point, so before the resistor here, or it could be the point after the resistor, so meaning here, seen after resistor, seen by the positive pole here. So you go through from the positive pole through the resistor and you land after the resistor. And when you do a pull up resistor, it's good, or we set our pulled up point of reference. So which point do we pull up? So we pull up the point after the resistor, seen from the positive rail. So let's stick a measurement probe in here. So, and if we measure now, so we have just done a little pole here for measurement after the resistor, and let's measure in reference to ground, what voltage this point has, and it is our supply voltage. This point has supply voltage. I think it's a little bit natural, because this pole, this positive rail here is connected via the resistor to this point that we want to pull up, and yeah, there is no current flowing. So all these points here, when there's no current flowing and you connect something to a polarity, to a potential, then all these points have the same potential along this route. And so that's this point here. So our 9.4. And now this, so we say this point is now pulled up. And so the question really is, okay, when this point is pulled up here, this black one, how do we get it? If it's put up, it's high, it's our 9.4 volt. How do we get it to low? And the answer is quite simple, that we just have to make a connection from this point to ground. Because what will happen then, when you connect now this point here, where this is put up to ground, then the point, one could say, okay, this point is connected then to the ground, to the negative pole of the battery. And so that was also an initial question on the video. So this point is now connected to the positive rail over the resistor, and is connected to the negative rail. And so the question is, okay, what potential will this point then there be at? And the answer is, you cannot answer it when looking at voltages alone, when looking at potentials alone, because then you would have to say, okay, positive potential coming up in from above. So this is at positive potential, as we have seen, and negative potential coming in from below. And then you would have the question, okay, positive and negative connected, what reference is, what voltage is this point at? And you wouldn't come up with an answer. But the answer is hidden in another phenomenon that is happening when you connect something to plus and minus to the same point. And the phenomenon is called current, and we will be able to determine what voltage is here by looking at the current and what the phenomenon of current implies here. So first let's connect. So we said, okay, we want to connect this reference point first here. Then we have connection to this side done, but we also want to connect it to ground lastly. This is a little bit of thing we have to do because the breadboard is laid out in such a way. And now this point is connected to ground. And now the big question is, what do you think when I measure here now? In reference to ground, what potential will this point be at now? Will it be positive or negative? Will it be ground or positive? Let's see. And it is, let's do it this way. Yeah, and it is sinking and sinking, and the answer is really, this has ground potential. So not quite, because there are measurement failures here, little small errors in measurement, but within the range of measurement and according to the theory, which we'll go through now, this point now is at ground. And the explanation for this one, and so if I pull this thing out here, and then we measure again, so no connection to ground made. Then again we have 9.4 volt. 9.4 volt level here. And if we connect the ground level again, so yeah, we're going to ground again with the vertical multimeter, and you see this point is now at ground. And so how does this come that this so we already explained when there is no connection to ground, of course this potential here is at this point is at positive supply. And then the next question that is answered, I think. And then the next thing is, okay, when we connect this point also to ground, then why is it then ground potentially at this point and not positive? And the answer is, once you have connected this point here also to ground, there starts current flowing through here. So from positive through the resistor, positive through the resistor, through the point, through these two jumper wires here, and then to ground. We have a nicely closed circuit then here, and through the battery, that's the circuit that flows. And when there flows current in a circuit, then all the voltage is dropped over the resistor that is in the circuit. In our circuit, this is the only resistor. Here, this is the one resistor, the 1 kilo ohm resistor we put in. And so all the voltage is dropped over here of the resistor. And because if current is flowing through resistor, then there is voltage over resistor. That's a simple law, and it is further specified or quantified by Ohm's law, how much voltage at which current is flowing, and then that gives the characteristic of the resistor. That's the resistance, or measured in ohms. Yeah, but going back to simple, it's like, okay, this is the only resistor in the circuit, then all the voltage is dropped over it. So you have on top of here, you still have the whole voltage, and we can also prove that here practically. Okay, I measure from reference to ground what this voltage is before this resistor up here. Oh, and it's okay. So nearly the full voltage. With regards to measurement errors, we say it's the full voltage before the resistor up here. And then after the resistor, again, we have no voltage left. And that's the simple thing. Over the resistor, the whole voltage is dropped. So first, this point is pulled high when there's no connection to ground made after it. And then if you make the connection to ground, then this point is low, because once the circuit is completed, then this point here is in a place where all the voltage has already dropped across the resistor, and so this point is then low. And so you can, and that's really a nice thing that is often used in circuits, you can say that you can make this point high or low only by cutting this connection here, or this one, any connection cut does it, or making this connection. And if you cut this connection, this point is high, and if you make this connection here, then this point is low, because if you make the connection, all the voltage is dropped over the resistor. So cut it high, make it low, and that sounds familiar. And that's also a thing used. You can make or break this connection here, not by doing this like I do, a complicated, okay, pull out this thing here and then stick it back in again. Who wants to do that? But you can use like nice little switches like this one. So see, with the symbol here, and you push them and the connection is made, and you release them and the connection is open. So this thing is normally open switch, so if you don't push it it's open, so it's normally open, and very often this is abbreviated with NO, big N, big O, normally open, NO. So because this is normally open, so if I put it in here, this connection wouldn't be made, so the point would be pulled high with a pull-up resistor. And if I would push then the button, I would have to do it right. Then this point, then the connection, the circuit would be established, current will be flowing, and this point would get low. So we can make this point low or high depending on if I'm pressing the button, it's low. If I'm releasing it, it's high. So I can control something. We can control it. And as you can think, the next stage is very clear. The next stage will be not using a button, but using electronically controlled button or an electronic control switch. That makes or breaks connection, and as you know, perhaps a transistor is such a component that you can use to control current, and that will be then the next step. But I just wanted to make the principle of the pull-up resistor here very, very clear, and I hope you enjoyed it. And yeah, perhaps we'll do another video with the pull-down resistor, but it's very similar. And for the moment, I wanted to thank you. If you want to give me a thumbs up or subscribe to my channel, that would be great. And I think we have lots of stuff to explore, and this is very interesting stuff. And I'm looking forward to the next video. Thank you and see you. Have a nice rest of the weekend, guys. Bye.